Okay, next bit of Unit 1 revision is bounds. So bounds come into play if a number has been rounded off to a certain value. So like if you're measuring something with a ruler, you will be given that measurement to the nearest millimetre, or to 1 decimal place if you are given the measurement in centimetres. Now anytime you give a measurement to the nearest centimetre, nearest millimetre, or to 1 decimal place, there's always cut-off points. There's a highest number that will round down to give you that number that it's rounded to, and there's a lower number that will round up to give you that number that it rounds to. And those two are just the bounds. So the upper bound is the biggest possible value that will round to give a particular value, and then the lower bound is the smallest possible value that will round to give a particular value. Now, I used to really struggle to teach this. Some of you may think I still do, but Miss Mawhinney actually showed me a wee trick that she does with it that is very, very useful. So I'm going to do it now. So we start off with a number line. So I've got 3 examples I'm going to work through here. So for example A, if we had to find, I haven't written out the question now, but if we had to find the upper bound and the lower bound of values that would round to give 2.4 whenever they were rounded to 1 decimal place, this is what I would do. So I draw my number line. I put the number that the question is about in the middle, so 2.4. Okay, leave a gap, and I'm going to say here that I go 1 above, but it's 1 of however much we've rounded to above. So because this is 1 decimal place we rounded to, I'm going 0.1 up. So next up will be 2.5, and next down will be 2.3. Now they're not our bounds, but they're there to help us figure out what our bounds actually are. And I think with ones like this, it's fairly obvious, but the ones that I find the trickiest are the really big numbers, which is going to be the last example that we look at, and this method comes in very handy for them. Anyway, to get the bounds, you go and mark on exactly halfway in between here. So halfway between 2.4 and 2.5 is going to be 2.45. Yeah. Halfway between 2.3 and 2.4 is 2.35. So these are our bounds, and I'll talk about this one in just a minute. So we draw a circle above here, above the 2.35, join it with a line to a circle above 2.45. Now if you remember with showing things on a number line like this, if you colour in the dot, that means that this number is included. So 2.35 is the smallest number that will round up to give us 2.4, because anything beneath that will round down to give 2.3 if you're going to 1 decimal place. 2.45 technically will round up to give us 2.5. So by not colouring this in, I'm saying that this is everything up to, but not quite including 2.45. So it's really up to 2.444, or sorry, not 2.49999. 2.449999. Yeah. Oh, flip, that melted my head. So that's how we show it. We show that this open dot shows that this isn't included, and the closed dot shows that this is included. And that little trick of going like 1 decimal point up and 1 decimal point down and then going in between is what works for me the best. So let's look at B. So 5.93, and that's been given correct to 2 decimal places. So I put that in the middle, 5.93. I go 1 above, so that's going to be 5.94, and 1 below, 5.92. So because this one was 2 decimal places, that's why I've gone up 1 here and down 1 here. Then go halfway in between. So halfway in between here is 5.935. Halfway in between here is 5.925. And again, the smaller one is going to round up. This one will actually round up to there, so we don't include it. That's why it's open. So everything from 5.295 all the way up to, but not including 5.935, will round to give 5.93. Okay, here's my challenge one. I don't know why these ones mess with me so much. I'm going to draw a longer number line to help myself out here. So we've got 3 million And we're saying that is a number that has been given, oh, I didn't even write it in, to the nearest million. Right? So 3 million has been given correct to the nearest million. So I go one above is going to be 4 million. And one below is going to be 2 million. There we go. And then we go halfway in between. So halfway in between here is 3,500,000. Halfway in between here is 2,500,000. That wasn't too bad actually, that one. So there are two bounds. 2,500,000 will round up to, or sorry, 3,500,000 will round up to 4 million. So it's everything up to. So that would really be 3,499,999.99. Yeah. Okay, so that's all you have to do, and that little sneaky trick of doing the wee halfway in between points works every single time. Okay, that's it for bounds. See you next time.